happening along. I'm Roland Pease. I present radio programmes sometimes on the BBC Radio. And we're here to talk about electric flight. I talk about an awful lot of things on the radio. I talk about, if you were here for the James Webb thing, I talk about stars, planets, vaccines, this, that and the other. I don't actually talk about electric flight very much. So I'm actually almost in the same state of ignorance as I suspect an awful lot of you are. But we are joined here by Dominic Weeks, who comes from a local company, which is, I think, one of the really things. Zero Avia, and you're based?
In Gloucestershire, yeah, just up near Kemble.
That's where you do your engineering, you do your flying out? And
it's our primary R&D site in the world. We're a Californian-founded business, but thanks to UKRI and Innovate UK and the money that the British government puts into R&D and aerospace, that's what brought the company here. We got most of our employees in the southwest.
And also, the one conversation I have had about this subject was from, if you can bring up the screen, all the way in MIT, the Massachusetts Institute of Technology. Stephen Barrett, and you've got a long, complicated professor of this, that, and the other at the Department of what? Talk us through, Stephen. Can we hear you? Keep talking. It will be there in a minute. Are you muted at your end? This is such a familiar phrase, isn't it? Are you muted at your end?
Any luck now?
Here we go.
Okay.
So
yeah, Department of Aeronautics and Astronautics, which means things to do with air and space.
The first time I spoke to you, it was actually about your concern about pollution and pollution that comes from normal airplanes, and we can talk a bit about that maybe later on. But the last time I spoke to you was about a really radical new way of having electric flight with no moving parts and everything. I'm not going to let you say any more about that at the moment, Stephen, because I think we're going to have the big reveal in a moment. But as you know, the world is connected, increasingly so. I think you've got a slide coming up on this. On the growth of flight, it uses hydrocarbons, fossil fuels, it's putting pollution and it's putting carbon dioxide into the atmosphere. It's one of the really hard bits of the whole economy to tackle in terms of global warming. But the hope is, if you can make an electric plane, then you get rid of those fuels. So, yeah, I thought, oh, come off it. Come off it, Stephen. But that's what you're doing, Dominic.
Yeah. So I almost thought it might be worth starting with a bit of a straw poll, because I heard this really interesting stat the other week. But I just wondered how many people in the room have close family that live abroad. Yeah, so almost a majority. And 1/3 of children in the UK today have a grandparent living abroad, apparently. That's the statistic that I heard. So you mentioned some of the challenges we have with incredibly polluting flights. If we move on maybe to the next slide, we've got a huge challenge for aviation in particular, because the percentage in growth means that by 2037 we'll have about 8 billion passengers. So the demand is not going away. People are trying to come up with solutions to try and restrict that demand, but our kind of raison d'etre as a company is that we don't want to stop people flying. It actually brings tremendous economic, cultural, societal benefits. And the solutions, while not yet ready, they are out there. So the key thing to focus on is how do we actually deliver zero-emission flight? Which is really hard in this sector. And aviation currently is only 3% of global carbon emissions, and I think we'll maybe bring in Stephen in a second on this, but it's predicted to be about 25% by 2050 as other sectors decarbonise. And with aviation, you have to think not only about carbon emissions, you also need to think about non-carbon emissions, so nitrogen oxides, contrails, soot. A lot of these other things have huge impacts at altitude and actually can be 2/3, scientists think, of the climate impact in total. whereas carbon emissions only a third. So
Stephen, are those numbers you recognise? Oh dear.
And can you hear me again?
Yeah,
or?
yeah. Those numbers
Okay.
you recognise.
Yes, I do. I think it's a big challenge for aviation because unlike almost every other sector where the main climate change affecting pollutant you care about is just CO2, for aviation you have to double it or even triple it depending on the estimates. The one thing I would say about it is that there is a lot of uncertainty because it's very difficult to work out how much more warming you get from these other pollutants. So it might be double, it might be a bit more, it might be a bit less. But what we're certain about is that it's these non-carbon emissions are extremely important for aviation.
And I think, as Dominic was saying, the trouble is that the world is becoming so connected. You can either go sort of hair shirt and say, right, okay, we're all going to stick to our own islands and or travel by train, or you can just try and adapt the technology, which I don't know. At what point did you, Stephen, think using electricity might be viable?
Well, I think it's really, in the very long run, I mean, you know, I grew up watching science fiction and things and just thought the future of the world in, you know, when I'm retiring or shouldn't be burning fossil dinosaur juice, fossil fuel, in sort of a technology invented, you know, essentially 120 years ago. And ultimately even using kind of rotating propellers and things like that seems very old-fashioned. And obviously in practical terms, we will be using that for many decades to come. But I also thought it's important to think about, you know, how will technology look when you think out 100 years from now?
I mean, so I think for me, the problem is that hydrocarbons are an amazing fuel. They are so rich in energy. All you have to do is pick up some oxygen, which is already there free for you in the atmosphere, put a match to it, let it come out the back of the jet, and it gets you, gets you anywhere. Whereas, you know, you think batteries, you think electricity, you think a AA battery, but you're going to correct me.
no, I mean, I think that the challenge is that with the energy density of available batteries today, you cannot match the combustion impact of a jet engine. Can't be done. The weight is just too great. So that is exactly why we have looked at hydrogen. So hydrogen, you can use it in two ways. You could combust it in an engine and burn it, but then, of course, you have all of those nitrogen oxides. You have those contrail impacts, what happens whenever you burn a fuel like that. Or you can use it in fuel cells. So essentially what you're using electrochemical reaction to use the hydrogen fuel to create electricity, and that then turns electric motors and powers an aircraft. And with hydrogen, it's a fuel that has an incredibly rich energy density. It has some challenges in that it's bulky. So it's volumetrically more
It's
challenging.
gas.
Yeah,
I mean, it's literally gas, unlike.
and we can come to that because it can also be a liquid, which is another big engineering challenge. But as a gas, yeah, it is definitely it has more volumetric challenges. So you need to manage the energy density and the range of the aircraft, and that's what kind of we're working to do. But it can deliver that electrification, so you have zero emissions.
Do you want to take control of that for a minute?
Yeah.
Because I know you've got a couple of slides which will.
Yeah, I'll try not
Show
to
us.
kind of do death by PowerPoint, but this just really speaks to what you were alluding to at the start, Roland. So people may have heard of sustainable aviation fuels. They are essentially, they come in two forms, a biofuel, so from waste materials or from crops, or a synthetic aviation fuel, which is created. Now, this is a drop-in fuel that can be used in current aircraft engines, but it won't tackle, as we kind of see here, those non-CO2 impacts. It won't fundamentally remove CO2 from in-flight. So it's not the answer for long-term
I have to say, I'm always a bit suspicious of this renewable aviation fuel. It seems to be displacing the issue rather than curing the issue of the burning hydrocarbons in a jet.
Yeah, absolutely. And so it helps, and we need it in the short term. But really, what you want to deliver is electrification, so you can get to that zero emission. And the kind of the key thing about hydrogen electric is study by McKinsey and Clean Sky, the European Clean Aviation Partnership, that found that hydrogen fuel cell can remove up to 95% of emissions system-wide. So that is why we're going after that technology, and we're doing that in Gloucestershire, just up the road.
So let's see is the next one what it looks like.
Yeah, so this isn't the engine. This is just to show you how, in theory, it works. And I think the easiest way to maybe describe it is you take sunlight, you take water, and then in a process called electrolysis, you split you use the energy from the sunlight, from renewable solar, or from wind, or whatever it might be. You use that to split the water into hydrogen and oxygen. The oxygen's vented off. The hydrogen you store, you compress it as a gas in the case of our first aircraft, but in the future we will liquefy it and use it as liquid hydrogen because you get better energy density there. And then essentially we refuel it like you would a normal aircraft. The refueler we have for our test aircraft, you can use it in a Toyota Mirai car. It's just like what you would see at a petrol station essentially. So that's kind of the model, and then the engine is very much like what we're doing is we're using the fuel cell, which is the fuel cell system, which is the blue portion of this, to generate that electricity. Then you have air compressors that keep the fuel cell running in the right condition, feeding in the oxygen to generate that electricity, and then you have inverters to convert the fuel cell power from DC to AC. Alternating current is what you need for an electric motor. You have electric motors, and then essentially you use those to turn the propeller. So that's how the system works.
That picture, but particularly among the kids of you, who's had a toy aeroplane where you have a little electric motor on the front? Does that not look? It looks the same, doesn't it? Yeah. It's just a little thing you could put on the front of your balsa wood thing with a battery somewhere, and it'll fly. So those are about that big. How big's that?
So this will be it's a 600 kilowatt system power-wise. It essentially would fit in the nose or in the engine cowling of a current aircraft. So it's not massive, kind of.
Yeah.
Big. Yeah.
600 kilowatts. That's trying to think how many houses that would run.
I don't know.
Well, your toaster is what, 1 kilowatt. So but that comes back to my point. Is you've got to deliver, whether it's through petrol or diesel or whatever, a lot of energy, and that's what you're doing here.
Yeah, absolutely, and this will replace. This is designed for 10 to 20 seat aircraft. So I don't know many people. I don't know if anyone has ever flown on an aircraft that small. It's not your. So a few nods though. So some people, yeah. So but I think for the majority of people, it's not the kind of aircraft they fly on. But these are in operation in the Highlands and Islands in Scotland. They're used as to transport cargo as well. So we're planning to get this engine certified and flying passengers and cargo by 2025. So just 3 years away. And then our vision is, I think on the last slide we had it, is a hydrogen electric engine in every aircraft because we think it's the cleanest, most practical and most economical way of doing this.
So, and it works. I think it's the next slide. So
hopefully it is. So just over or around a month ago, about 3 weeks ago, we tested the prototype of this system for the first time in flight. So we've been running it in ground tests on a Dornier 228 aircraft, and we tested it for the first. So it's a 19-seat aircraft. Tested it for the first time at our airport in. I think it's going to play. Hopefully, here we go. Cotswold Airport in Kemble. So.
Which is a fabulous airport in its own right.
It is. It's really good, and it's got. People may have heard of Vertical Aerospace. They're doing their testing at Kemble as well. But this was the fruit of kind of nearly 18 months of work. We got the aircraft in September of 2021. Immediately took the left side engine off, and we've retrofitted it with the hydrogen electric engine. And this was the day we kind of took it out for the first flight. It was an incredibly emotional experience, actually. I was on the roof of the control tower. We were filming from here, and I think everyone hearts and mouths because it's experimental testing. But essentially, that left side engine is producing no emissions. It is producing water vapor at low temperatures. So in the future, that's something that we will be able to mitigate any contrail impact for because it's at very low temperatures. It's not like a combustion engine which is throwing it out at 800 degrees. But yeah, it was a kind of 10-minute flight up and around, and we've since flown the aircraft a couple more times since and have a program of about 20 flights ahead. And then after this, we will look to scale the technology for 40 to 80 seat aircraft by 2027, regional turboprops, and they would take you, I flew on an ATR 72 recently from Bristol to Dublin. These are often used. Dash 8 is another aircraft. So we think we can get this up to scale of moving a lot of passengers before the end of the decade.
Is that only one prop being propelled by?
It is only one prop.
I tell you what, if I was piloting that, I'd want to be sure that one engine was going to work when everything else went wrong. Is that right?
That's exactly right, and the CAA, the regulator, also want to be sure of that. So what they gave us the permission to test that engine. But it's it's standard aerospace way of doing things.
Sure, but nevertheless, I mean, to me, that when I saw that video, it was actually only about a day after I contacted you to say, could you come and talk to us? And then the next day you did that flight. And I thought, to me, it's really amazing because I simply didn't believe you could get that amount of power through an electrical system into a motor. Like I say, I think of electrical. I know we've got Teslas, but this is presumably somewhat more powerful than a Tesla engine.
No, absolutely. Yeah, much more. And we initially did this I think this just shows the progress. We initially flew a 6-seat Piper Malibu from Cranfield Airport a couple of years ago, September 2020. So in the space of those little over 2 years, we've been able to more than double the power output of that system. So it gives a lot of promise to scaling it up.
All right, now, we won't tell anyone else. Did you go in any of those flights yet?
No, they won't let. They'll only let our test pilot and our flight test engineer fly it. So
how's that going to progress? At what point do the authorities say, okay, now you can take some other people in?
It won't be. I don't think it will be until it's certified. We'll be able to take other people up in the aircraft. So yeah. So we have to get through the base of certification, and then we'll be able to start flying passengers. Yeah.
Go on, you're tempted, aren't you? You are tempted.
Well, I mean, with the previous experimental conditions we had on the Piper, our CEO flew the aircraft himself, and various other people went up as flight test engineers. But with this, it's much more strict. It's getting larger. It's a different ball game now, really.
Stephen, what do you make of that?
I think it's a very, very exciting development. I mean, it's there's for large scale aircraft, civil aircraft that fly tens to even hundreds of passengers. Battery electric essentially isn't an option for the reasons Dominic outlined. That the energy density, the amount of energy you can store in a battery, just isn't high enough now. And short of some huge breakthroughs in the science and engineering of batteries, we aren't going to be able to have large aircraft that are battery powered for a long time. So that leaves really two options. One is hydrogen, which is what that aircraft is powered by, and the other option would be sustainable aviation fuel. And they both have some pros and cons. I think at a global scale, many different organizations are putting forward products that are on one side or the other. But globally speaking, it's not yet clear which of those paths is the best path yet. You've got companies like Dominic's one and Airbus for larger scale aircraft that are proposing hydrogen, and you have many other companies that are saying, well, sustainable aviation fuel is a better approach. So there are some sort of objective differences between them. One is that the sustainable aviation fuel has a higher energy density, so it doesn't have this challenge of the bulkiness, which is something that was talked about. So that sort of means that you could use sustainable aviation fuel in existing aircraft, and they can fly as long range as today's aircraft. On the other hand, hydrogen fuel does burn cleaner, so it won't produce soot like sustainable aviation fuel does. So there are a range of pros and cons between the two.
So
the one thing I would say is that...
Are you saying in principle you can put hydrogen gas through a jet engine the same way as you do jet fuel at the moment?
Absolutely. I mean, hydrogen is a great fuel to burn. I mean, it really wants to burn. Very, very easy to burn. So, I mean, it will cost a lot of money to do all the testing and certification, but that's engineering that can be done, and there's nothing fundamental. And in many ways, it's easier in terms of the actual combustion process. The challenge with hydrogen is more around storing it, because it has to be stored, as was just talked about, at a very low temperature to keep it in liquefied form. Otherwise, you don't want to fly an aircraft the size of the Hindenburg, right? An airship. You want things to be contained, and that means low pressure storage to keep the gas liquequified.
I was going to say, thanks for bringing up the Hindenburg, Stephen.
Well, I was going to ask a similar kind of question. Where is the hydrogen? I don't know if we can get back any of those pictures.
So for the test bed, it was it's inside the cabin of the aircraft basically. But for the for those first models, it'll be wing mounted tanks.
And is it cooled down to be a liquid, or is it compressed into?
We can get so quickly to certification because we're using a lot of learnings from road transport. So that's why we're going after a gaseous system first. Stephen mentioned there are challenges with liquefied hydrogen. You store in terms of storing it, and a lot of work needs to be done on airport regulations and standards about how you use that fuel. So that's a bit further out, but we still think is more than doable this decade. So we're starting with gaseous. So it needs to be pressurized to about 350 bar, which is about the same that you would use in a
That's 350 atmospheres.
Yeah. So it's what you would use in a fuel cell road vehicle.
And so what is it in cylinders, or do you say you pump it into?
Yeah, it's in tanks. Yeah. It's
in the main body of the plane. People laugh just now about the Hindenburg, but you have to remember that when you go on a jumbo jet or something, those wings are they're stuffed full, aren't they? Of
one of the most flammable
materials.
And hydrogen is. I think people don't also necessarily know that hydrogen is used extensively across the world in industry and and now has been tested in road transport. A lot of hydrogen trucks are coming in. Obviously it needs to be managed carefully and it needs to be regulated, and that's why the CAA, the FAA in the States will look at this really carefully. But there's no fundamental reason why it should be considered less safe. It has a higher ignition temperature than jet fuel, for example.
The other thing is that maybe I don't know if Stephen wants to correct me on this. Someone said to me a long time ago, the great thing about hydrogen is it's a very light gas. So if you breach the containment, what it does is it goes up in the atmosphere, whereas your kerosene or something will just pool around you. So the Hindenburg has given hydrogen flight a bit of a
bad name, and that is an amazing thing, isn't it? Because we want to get this technology introduced, but obviously people will be nervous about it because you talk to 15-year-olds, 16-year-olds, and they ask, what about the Hindenburg? It's like it was 100 years ago. It's really stuck in the public consciousness. So I think seeing things like our flight, seeing others fly with hydrogen, Rolls-Royce just tested a hydrogen engine, a combustion engine. I think that is the kind of thing that will start to get people more comfortable with the concept.
We'll come back to more of that in a minute, but now, come on, let's, Stephen, give us a reveal of your. I mean, it absolutely caught my imagination. This is a plane with no moving parts. Far away.
Yeah, so this is sort of a project I started when, actually over 10 years ago now. So it took this is sort of a very different speed of progress compared to the kind of engineering that Dominic's describing, because it requires some sort of fundamental advances in understanding of how you can move fluids, liquids, or gases around. So the basic thinking was, well, if we think out into much further into the future, should we still be using propellers or turbines to propel aircraft? And maybe we will, but it's worth asking: are there any alternatives? Now, around over 100 years ago, a different way of moving air was discovered, and that was called electro-aerodynamic propulsion. So the idea there is that you essentially take air molecules and strip electrons off them with a high voltage wire that makes them charged, so they become positive. And then you can move those molecules, called ions now because they're charged, in an electric field, which means that you then have a stream of charged air molecules moving, which then collide with other air molecules and create a kind of wind. So this is a way of creating an airflow that is created without any moving parts, without any propellers or rotors or turbine elements.
Can I just illustrate? If you go back to that picture, very briefly, if you can, are you saying that essentially Newton's laws of motion apply to those ions that you're pushing out at the back in the same way as they apply to the jet fuel, burnt jet fuel that comes out the back of a jet. It's still pushing effectively on your machine.
Yeah, it's just that in the case of, say, a jet engine, the thing that actually does the pushing is something that looks like a rotating propeller that spins inside the engine nacelle. So it's still like a propeller. In this case, the thing that pushes the air are charged air molecules, ions. So it's sort of charged particle that bumps into other particles and pushes along the air.
Okay, let's see. So you got the design, I think, on the next slide then.
Yeah, so we over some years designed an aircraft that would fly using this approach. And if you look under the wing of the aircraft, you can see here a configuration a bit like I showed before, where there are these thin wires that what's called ionize air around it. That means they strip off electrons from the air, leaving behind positively charged air molecules called ions. And if anyone's ever felt an electric shock when they touch something on a dry day or have rubbed a balloon in your head or something, that's the same kind of force we're talking about. It's called electrostatics. And then you can see these small airfoils that are the things where the ions eventually hit those and become regular air molecules again, get neutralized. So we were able to test fly this indoors. And this is an example of a flight which was completely silent, no moving parts, but a very short flight, just 60 meters or so, actually, as it happens, about the same length as the Wright Flyer from years ago. So that sort of showed a kind of first demonstration of flying an aeroplane with no moving parts. And that was very exciting for us because it took about 9 years to get there, something like that. But we're not going to stop there. We're going to keep on trying to push this technology forward to see if we can make it into something that's ultimately going to be useful.
I mean, what's that feeling like? We were just talking to Dominic, seeing their hydrogen-powered one taking off.
I think Dominic might be able to sympathise with this. At one level, it's sheer terror, right? Because in this case, the aircraft has 60,000 volts wires exposed. So you're concerned about health and safety, and for anything experimental, you always will be. Even more so if it's something like what Dominic flew with people on board, then that's a real concern. So I mean, a lot of it is. In my case, at least, I think much of the joy would be after the fact, once you've know everything happened safely and it all worked.
I mean, did it ever spark? I didn't realise that the voltages were that high. That's just to create these ions.
Yeah, there is from one crash test flight. There is a scorch mark on the floor of that gym there somewhere, which I haven't revealed to the authorities, but there is a burn mark that will forever be there.
I can't see on there where the battery is, and I mean, presumably if you're getting you said 60,000 volts. Oops. Are you still there? Yeah.
Yeah, I think it froze for a second.
Yeah. Where's the battery power, and do you have to do conversion and stuff to? I mean, I can't see anything apart from the wings, basically, in the bits that you were talking about.
Yeah, so this is battery powered, and in the long term, you could, in principle, power it using an approach essentially the same as Dominic's aircraft, where you might have a fuel cell to convert hydrogen into electrical power. In this case, the aircraft contains a battery, as you'd expect. The other key component of it is what's called power electronics. So this is a set of circuitry that changes the voltage from the roughly 200 volts that comes out of the battery stack up to 40,000 volts. So power electronics is a major part of the engineering of any kind of electric aircraft, whether it's these kind of small experimental prototypes for the distant future or the kind of nearer term, larger scale aircraft that Dominic's talking about. I mean, managing the electrical power effectively is a really important thing.
I mean, that one's only small. Have you thought of marketing those? I was just wondering if in here, as a toy plane, this would really impress your friends. Who would take one of these to school and say, yeah. I mean, it like you said, Stephen. It's so space age to use ions and the idea of some kind of electric glow in it, because it looks like a glider in a way, doesn't it? I don't know if does anyone have any questions? Yeah, go on. Do you want to ask a question? Because I do.
Is it like a power energy?
Is it like a power?
What is it powered by?
So it's powered by battery. Oh, does it? So it's powered by.
Sorry, Roland, I didn't quite hear that. with
No,
the
he was
microphone.
asking if it's powered by a battery, effectively. And
Yeah, it's powered by a battery. So this is a
Can you
set
hold
of
up your hands? Show us
lithium.
how big the battery was.
Well, each cell is very small, so it's a stack of
How?
lithium polymer batteries, just like you have in a mobile phone, essentially. But we just stack them all up and chain them together, because if you join a lot of batteries together, you increase the voltage you get out of the battery. So a bit like with AA batteries, sometimes you put them into a device and you'll chain a few of them together, and that gives you a higher voltage than you'd get just using one of them.
And how much thrust were you getting? I mean, I don't know if you've got numbers. I don't even know how you quote these numbers, Dominic, for the thrust that comes out. It's obviously a very light machine. I'm just sort of wondering how you get from that to something like Dominic's doing, to a single-seater plane or something like that. Is this just, will this always be a toy, or do you think there's a way to make this, commercial proposition?
Yeah, I mean, the prototype I just showed had a few newtons of thrust. So 1 newton is the thrust you would need to lift 100 grams, and 10 newtons, or actually 9.8, would be what you need to lift a kilogram. So, if you just measure the thrust, it wouldn't even lift a kilogram. So it's quite small. But obviously that's the first one, and going forward we are trying this year to build another prototype, which version of the design is shown here, which will fly outside and carry a small payload and weigh a lot more. So we're talking about a lot more thrust. The aim of this next stage in the work is to make a kind of aircraft that is vertical takeoff and landing, and
you just rotate the
essentially
wings.
silent. Exactly. So on the left here, you can see how it would look with the wings rotated, creating downward thrust. And then on the right, that's how it looks in flight. So this year, we don't think we'll get to doing the vertical takeoff part, because that's hugely challenging given the amount of thrust needed. But the image on the right, the horizontal flight, we do think we'll get to, and that'll be the first outdoor flight with a much larger, heavier aircraft. And longer term, this is how we think it will end up looking, with the thrusters embedded within these wing boxes.
I mean, would the very first picture that we had for the session had all those drones sort of doing fancy things around some kind of cityscape? And in a way, I think our view of electric flight has changed, just because you can get pretty impressive electric battery-powered drones doing things. Is developing this into a kind of drone configuration an option? I just don't know quite how you move forwards and get people to start saying, Elon Musk to say, here's my billion or something.
Yeah, I mean, I think that's sort of the path, is that this is not going to be carrying people, in anytime soon, if anything, because there are good alternatives, and the development and the safety would be, really challenging. Also, in terms of need, I mean, the big challenge with drones in the urban environment is they're incredibly noisy. And I mean, things like package delivery, where it has been trialed, has been strongly criticized by the local community, because it's like having small helicopters flying around your urban environment. So the near-term problem that can be solved is making drones silent or near silent. So as you suggest, having vertical takeoff and landing, silent drones, I think, is the near-term thing that can be done. And then when you go on Amazon and order something to arrive, next day, maybe in the future, rather than having that somebody coming up your driveway and dropping off a package, it will be a silent drone dropping it into your garden.
I mean, it's a fantastic vision. And just give me the sense, you say that it's silent in a way, like a glider. Did that spook you at all when you saw those first flights?
Well, it was surprising that the aircraft sound was quieter than people running in the gym in the background. So you could hear footsteps, which were louder than the aircraft. So it's not 100% silent, but it was quieter than the footsteps of runners.
Because I was wondering, Dominic, with your most of the noise we get out of even an ordinary propeller plane
Yeah.
is presumably from all those cylinders and things banging away, or the turbines spinning. You've presumably been close up to your electric engine.
Yeah, and it's definitely quieter, anecdotally. We haven't measured it in any way, shape or form, but the vision is that, I mean, we anticipate there'll be a noise reduction, which is beneficial for communities. And the other element of it is if it's not the engine noise, that's kind of a continuous hum. With the propeller noise, it can become much more single directional. So you don't have it, if it's flying over your house, you wouldn't have it for as long, basically.
Right, so it sort of shoots out in one direction
exactly.
or another.
So the noise profile is a definite benefit. I think the other thing, just in reference to Stephen's design, which is incredibly exciting, is one of the big benefits of moving to electric flight and removing combustion engines, aside from the environmental, and this is actually, funnily enough, the one the airlines like a lot, is that you've got less moving parts in those electrical systems and they're less prone to failure. So you have to have major maintenance and overhaul events far less often. So therefore, the costs come down. So people are often asking us, but are we really going to pay for more for green flight? Are people going to want to pay an extra £20 like you do, or £5 when you offset, and no one actually goes on and does that? Well, the answer is actually this could be cheaper. So people should be enthusiastic about having lower fares, not higher fares.
It's interesting you say that. I remember someone once saying to me that the business model for the big companies like Airbus and, well, particularly for Rolls-Royce, is a bit like those printers you buy at home. They make the money out of the cartridges, not out of the printer in the first place. And a huge part, as I understand it, of Rolls-Royce business model is the maintenance contracts that keep the aeroplanes in place, because they're, as you say, there's so many moving parts, they're so complicated. That's an interesting one. Your plane, it was the Dornier is a 20-seater, did you say?
Yeah.
You're thinking of going up to...
So the first two steps will be that 20-seat category, 10 to 20 seat, and then 40 to 80 seat. But we've got really no plans of stopping. We have an idea of how we'll be able to do a 10 megawatt engine, which essentially would support narrow body aircraft, so the A220, A320 Airbus aircraft. And then you're talking, 100 plus passengers. When it gets to the very large long haul wide body, that's probably a couple of decades away.
So you think it is? You and your investors think that that's a plausible future?
Well, importantly, not just us who are obviously selling this vision, and we're very excited about it, but the UK has the Aerospace Technology Institute, which funds a lot of the research and development. They also have had a program where they brought a lot of experts out of industry. It was called Fly Zero. It was a year-long program. And they identified that a hydrogen combustion, this was a combustion engine, but a hydrogen combustion engine would be capable of flying a mid-size wide-body aircraft anywhere in the world on just one stop by about 2035. So it's not...
That's around the corner.
And Airbus are also looking very, very carefully at both fuel cell and hydrogen combustion. They're taking this really seriously. They're a bit further down the line on that timeline. They're a bit more cautious. But yeah, that independent body in the Aerospace Technology Institute does think that we can get to larger aircraft pretty quickly.
I mean, the reason I asked it was going back to that first picture again with all the little drones and things around. Is it with the kind of stuff you're doing with the small planes, I was wondering whether we may also see along the way a change in the whole pattern of air travel, that it's more, it's not this hub-to-hub thing with great big planes, but actually you're going more from point to point and so on.
Yeah, this might be a bit prosaic, but I think something that excites me is the idea, I don't know if anyone's been on a 6-7 hour train journey in the UK, and it's like, it's not, if you actually add the mileage, it's not very far. So I don't know, Swansea to Norwich or something, always having to go in and out of London, which is essentially it's kind of a Victorian train network. And why not fly direct? And these smaller aircraft, I think, can come in and create a market there. We're not banking on that. We're kind of focused on, numbers-wise, what's the existing market to replace. But there's definitely an opportunity for us to fly more, shorter distances, and then from airports it could be an air taxi into the city centre as opposed to getting on a train. Yeah, so there will be changes to airspace, I think, over the next few years.
I mean, it's going to be, Stephen, you're in the States where air flight looks a bit different anyway. I mean, besides making planes like this, do you get involved in the conversations with the manufacturers and so on?
Very, very much so. And most of the work I do is focused on making aviation more sustainable, in particular large commercial aircraft. But I have also done some work related to what in the US is called general aviation. This is private pilots with their small aircraft, Cessnas and things like that. And unlike in the UK, where that's a very rare thing for people to own aircraft personally and fly them around. In the US, it's actually quite common for people to own aircraft and fly them as a hobby or as a means of transport. Large country, many small airports, very low costs of owning and operating a small aircraft. And it's a different way of life for some people when there are even communities that are focused around airports, and there are kind of airport communities where all the houses are near runways and things like that in some parts of the US.
And does Dominic have competitors out there as well? I mean, presumably this is a space for lots of people to get into.
Yeah, there are competitors here, all working on slightly different things. There's, for example, a company called Universal Hydrogen that is proposing a way of storing hydrogen on aircraft, and they have a particular solution, somewhat complementary to what Dominic's doing, but it's a hugely active area. Then there are companies that are working on urban air mobility. So this is essentially the vision of air taxis, that you could get an aircraft from the center of the city out to the airport, and you'd get in a small vertical takeoff aircraft that would get you there. Quite a few companies in the US trying to build that vision.
I mentioned Vertical Aerospace, which is a Bristol-based company, which is also testing at Cotswold Airport, and I think that it just raises something else that's really important. I think for Britain and for the region in the southwest, which has always had a strong aviation industry, is that I have to confess I'm an English literature graduate. So if anyone asks if anyone asks any too deep probing questions on the technology, I'll hand it over to Stephen. But what I see coming through Outdoors now constantly is a stream of incredibly excited graduates. They're not starting a career in their engineering careers with the kind of guilt about what they're doing to the planet. They think they've got real purpose in what they're doing. And I think if we can get these technologies built here, manufactured here, and exported, these are the technologies that the rest of the world are going to depend on. And there's great, exciting careers for young people who do what I didn't do and spend more time on their science, engineering, and maths.
I mean, out of interest, do you or the airport or anything do visitors' days or anything like that they can, or are you going to? Can we persuade you to?
Yeah, we have done it. We have done a few, yeah.
Because I just imagine, you're just down the road. We got thousands of children learning in our schools here in Swindon, who I think would be...
No, we do have school visits, so we like to do that.
Yeah, absolutely. When you talk about flying taxis, and funnily enough, the first one of these talks I did at the very first Festival of Tomorrow was, Buddy, Where's My Hover Car? And I don't know if there are people in here who, I just get to think, isn't that a bit, wasteful? Isn't it a bit consumerist, getting a hover taxi? I don't know. Are there people in here who think it's all very well finding another way of polluting the planet, but no thank you? Because I think there's still, I think there's possibly still a... Go on, sir.
I just think it's very interesting and
Okay, I've got a microphone here.
I think two things that what concerns me is that these will be playthings for the rich, and flying from Swansea to Norwich, the example you gave, surely we should be looking at developing better mass transport rather than using the Earth's resources for what could be. I mean, we've already got a problem at the moment with rich people using small aircraft, and that's that's using existing technology and polluting. But so I can see the advantages from moving to the new technology, but I still think it's a rich person's plaything.
And rather than answer that yet, there was another. Did you have a question back here? Yeah, hang on, just wait for this microphone.
This was related to something else you said earlier. you said that this that might be like a toy, but wouldn't that be kind of dangerous because it has live wires? And
I'm glad you're thinking about this harder than I was. That is such a good question. Stephen, can you make a cat-friendly version of this?
Well, I have two cats, and they haven't been fried as of yet. But I do think that was a very good point that this, anything that has the capacity to fly, is quite dangerous. And whether it's high voltage, exposed wires, or it's a spinning propeller that could seriously injure a feline or other person, or it's a combustion chamber, which is like a controlled explosion. I mean, in all of these cases, we are talking about large amounts of energy that are needed to propel something through the air. I mean, that's why it took until just over 100 years ago to sustain flight, right? It's a really hard thing to do. And we had the Industrial Revolution for over a century before that. So, I mean, it's difficult to fly. It's at the edge of what's possible. And you have very innovative companies like Dominic's that are pushing the boundaries of what's possible in the coming decades, and universities looking even further ahead with smaller scale things. But it's difficult. There are dangers. Those have to be managed really carefully. And getting back to the first comment, I mean, I think because we're talking about significant amounts of energy, that does mean that air travel is resource intensive. And I think the way to, you could say, well, one solution is just not to fly, right? That's one possible future for the world. But I think when you look at the world, especially as it is today, we have, wars going on and things. I think we want a more connected world with more cultural understanding and more interdependence across all people. We don't want more separation and less cultural understanding. So I think a future of the world with more aviation, not less, is a better world. And the solution to that isn't to just stop flying. I think the solution is for creative young people to go into science and engineering and invent the technological solutions that will make the future of flight green and affordable to everyone, and to connect the world so we can have a peaceful and prosperous future.
I don't know if Dominic, you want to add something, or shall we take another question first, and then I'll come back to you?
Yeah.
I had this idea for if we had not kind of flying cars, if under the ground there would be these magnets that could allow it to lift up a bit, and then say if it parked, there would be wheels that would just flip over, and then they'll flip back to normal, and there would be these little propellers that would make it go down slowly. And I thought there could maybe magnets that can help push it around, and some other propellers on the back. So that's a way flying cars could be.
No, I like that. And there is this thing called magnetic levitation, these maglev trains. You've got a recruit here, I think.
Oh, yeah,
I mean,
wow,
honestly, keep thinking difficult ideas, because that sort of Stephen just disappeared for a moment.
He's gone off to patent.
Oh, I'm back again.
No, honestly, it's by having ideas and, okay, how do I make that work? That is science and engineering. Can I just come to the man behind you?
I think it's a very good idea as well.
I was just going to ask whether or not you thought the recent developments in propellers with toroidal propellers was going to help close the gap to jet engines.
Yeah, I think it's a very innovative idea, and that was actually created by somebody if I'm thinking about the same product anyway, the same design, it was created by a collaborator on the same team that designed the earlier version of this aircraft. So that person's work was inspired by this, trying to come up with something that's nearer term, but still a big step forward in terms of noise reduction. So I think that will be a nearer term solution than the electrostatic approach.
Maybe I'm misremembering the technology. There's something called ramjet or something where the plane is flying so fast that it's taking a huge amount of air and doing something differently. Is that?
I think we need the professor of aeronautics on that one.
Well, I am a professor of aeronautics, so I can answer that. The ramjets, you could technically say, do have no moving parts, but they only operate at supersonic speeds, and so at that speed, the sonic boom, which is the noise you get from supersonic flight, is dominates any other effect. So, you wouldn't be too concerned about the engine noise when you're flying supersonic.
Come on, there's yes, we've got another question. Sorry, this is good for my step count. That's it.
I wondered whether you gentlemen had any comments about the 4 objects that were shot down by the Americans. 3 of them were balloons.
Confess, Stephen, confess.
But the 4th one they described as an octagonal shape with strings hanging down and no apparent means of propulsion or lift. And then they've gone very quiet. So I wonder whether that's one of your competitors who's already solved some of the issues.
I'll say something, and then Dominic can hopefully have time to think of a good answer. I think this takes us back to our earlier discussion on the Hindenburg. That long before we had heavier than air flights, which is aeroplanes, where the aircraft itself is a heavy lump of metal, basically. We've had hot air balloons going back thousands of years, and they were first flown in China, going back a very, very long period of time. Those were paper balloons with candles that would where the heat from the candle would make the air inside the balloon less dense. And since the balloon had less dense air, Archimedes' principle means it would rise. So I presume this octagonal thing probably is using the same principle. I don't imagine this is any kind of alien invasion we need to worry about quite yet.
And we've got a question here, sir.
How expensive would a commercial plane be?
Yes, Stephen, is your technology going to be more expensive, even in the long run?
It's really hard to know. I mean, it's got no moving parts, and similar to Dominic's company's technology, fewer moving parts means less maintenance. But it's also a new technology. Lots of uncertainty. There'll be unknown problems in the future to tackle. So I think we just don't know at this point.
I mean, I think we've got a future business graduate here, because I didn't ask that question, Dominic. What's the difference in price?
So, for us, it's crucial that essentially it's cost parity or very close, because the companies we're selling these engines to are not making vast profits. They have low margin businesses. So cost parity is what we're aiming at for the engines. And what we're doing is essentially we're working with existing airframes, so existing aircraft. So essentially it's same like for like cost replacement. In the future, when you have more space age design, and we are also working with companies who are designing new types of aircraft, because that might get more out of the technology, out of the new propulsion source, and so you therefore might have lower costs in terms of operation. But those aircraft, I don't know where they'll be in terms of the cost.
And I think it's an interesting connection with all we got. Rather than me talking, because the audience is doing better than me at the moment.
I've always wondered. I know, fantastic on the electric front. I've always wondered, having seen Concorde take off so locally, we have that technology. And we seem to be going backwards in terms of supersonic. It's obviously very simplistic, but surely if we get there, I know the total vision is to go electric, but surely if we get somewhere twice as quick, isn't there half the pollution? It's clearly not that simple, but Concorde was such an awesome plane. Why is... Surely speed is to get to... I've got my brother in Australia, so speed to me is paramount.
Yeah.
Why do we not have that technology now?
So
we do, but not use it.
Perhaps there's more room for that when more of your European trips, more of your domestic trips, then those are zero emission, because you'll be taking out a lot of emissions from the system. But long haul travel is typically the majority of emissions. It's a huge percentage, and there is a company, Boom Supersonic, which was trying to kind of revive the Concorde vision. I think Rolls-Royce pulled out of that. The appetite for going faster with a vast amount of emissions, I don't think is massively there in the sector at the moment, because everyone's under so much pressure to decarbonise.
Stephen, could you just put me... there's something about the amount of emissions on takeoff, and even when the planes are sitting on the apron, I think is the word you use, isn't it, compared to the cruising flight. What are the numbers?
Well, I'd say for supersonics, we're talking at least double the fuel burn. So, to the point on the question, the flight time is lower, let's say by half. But when you fly faster, you don't use you use more and more fuel for every increment you go faster. So it's sort of roughly a square law, meaning if you double the speed, you might be using 4 times the power. So it does work out that you end up using a lot more fuel to go supersonic. I mean, I do think that within the lifetimes of hopefully most of the audience, there will be supersonic commercial aircraft, but that will be some time off. And really, just for the reasons Dominic said, that in the in the 2020s, the urgent priorities are sustainability, using less energy. We don't want to go backwards in the sense of not having global air travel, but we've all just come out of a pandemic where we now know that it's rare that we have to fly now to go to a 1-hour meeting. If this was 5 years ago, I may have flown across the Atlantic to be there with you today, but in 2023, it doesn't make sense anymore. I can just join you by Teams or Zoom or whatever product. So we tend to now fly much more when we're going for longer trips than in the past. And I think that's unlikely to change with increasingly good communications technology. We'll still want to travel, but it's the nature of why we travel will change. And I think that reduces the benefit of supersonic aircraft in that you probably won't go to New York for a 1-hour meeting now, where you may have done 5 years ago.
We've got one more question here.
And going on from your idea, it's like a car. So if you're going slower, you burn less fuel. But if you want to if you're in a hurry and you're trying to get to a place, you're more likely to burn a lot more fuel.
I think you've been paying attention. So, I think we're probably out of time. I don't want to stop the questions. We've got one more here. Let me just quickly check how we are actually into our last minute. I've got to say thank you.
Hi, so question for Dominic. How's the energy density of these hydrogen fuel cells compared with avgas? Are we talking like sort of 10%, 50%?
So with avgas specifically, I don't have the number on that, but essentially for the system, we're trying to match the performance of the aircraft, right? So we have to what there will be is a slight range penalty because it won't be as energy dense as existing engines. So we're looking at around initially half the distance. But the important thing is that while it has a lower energy density than an existing engine and can't fly as far, we'll preserve the passenger payload. And most aircraft don't fly anywhere near their full range. So we still think we can get to kind of the vast 95, 99% of emissions that are flown with these aircraft. So yeah, it's definitely lower, particularly with a gaseous system.
I think it's been brilliant. It was very nice to hear about the stuff, the visits and stuff that you do with schools. Just very, very briefly in the last minute, Stephen, I think people have noticed you don't have much of an American accent. Tell us in a minute or so how it is that someone from, I don't know which part of the UK, ends up being a professor of aeronautics in MIT, one of the best universities in the world.
Well, I'm from London, so yes, I'm sorry I don't have a proper American accent. That's like and you don't want to hear my impression. That wouldn't go down very well, and I'd probably lose some friends in the US too. But I'm from Finchley in North London, and I went to Cambridge University when I was 18 as an undergraduate, and first went to MIT as an exchange student. So I did a 1-year exchange, and that's how I first was introduced to MIT, which is near Boston in America, and then came back many years later to be a professor.
I mean, I think it's one of the great things about doing science is you do get to go around the whole world and meet amazing people. And sometimes people come to us here in Swindon and say, thanks so much. I think we need to do this again in a year or two, maybe 2 years when the experiments and the flights are getting a bit further on. But it's been a brilliant audience as well. Thank you so much for all your questions.
Thank you.
Can we applause for our guests? Okay, thanks.